Okay, for those that weren't here yesterday, Grace, you got books there? Grace, books? Okay, let's get going here, please. Can I get someone to be brave to do the top left corner for me? Go ahead, Julie. Oh, great. 3 to the 6, x to the third, y to the 9. So what she just did there correctly, by the way, was 2 times 3 is going to be 6, and divisible 1 times 3 is going to be 3, 3 times 3 is 9. Did your parents come to interviews last night and just get me?
No, my parents
Did I ever mention that I'm not married to your father, but your father married my wife and I? Did I mention that to the class yet? Okay. I'm not saying to your father. I said, that slipped once that I said that, but anyway. Top right hand bracket, please. Can someone else be brave? Please, yeah, go ahead. Close to one small mistake. No. 3 to the negative 3, because remember how this goes, there's a visible 1 there, right? So 3 to the negative 3. Okay. Okay, can I get a third volunteer to do the denominator, please? Yeah, I want to go ahead.
3 to the 8, x to the negative 4, and y to the negative 6.
Great. Okay. So again, this looks like a horribly intimidating question. Okay, but if you take a look at just 3 small parts, I didn't bring them together. Can someone be brave now and simplify the numerator for me, please? No one's brave. Luke, go.
3 to the 3,
Yeah.
x to the negative 8.
X to the negative 9. Negative 9, I think, right? Okay, now by the way, if you're sitting there saying, I don't know what's happening, now's the time to ask, because we're cranking up the intensity by about 10 times worse than this today. Just want to make sure this is all good. Tyler, you good? Sort of good? A little bit good? Tristan, all well?
Yes.
Okay. Now, this dividing now, the rule for dividing is subtraction, but some people get mixed up beside negatives all over the place. Can someone be brave and simplify those for me, please? Oh, when you're on fire, go ahead.
3 to the negative 5.
Yeah.
X to the negative 5.
Yeah.
Y to the 2 times 1.
Okay. Can someone explain to me, you're correct by the way, why no one's correct? What did he actually do there? Why does that good? Yeah.
Subtract the exponents.
Yeah. So it's going to be like 3 minus 8 is negative 5. Negative 9 minus negative 4 is like negative 9 plus 4. Right, and then 15 minus negative 6 is like 15 plus 6. Are we okay on that? Because that's like the one stumbling block people have for that. Any question?
Yeah.
Okay, so basically what she already read here. So like, if you look at your exponent, it's just subtracting, right?
Oh.
Right, so again, you're going to subtract them, so it's going to change to plus. All the negatives will be like adding and bigger, right?
Oh, okay.
Can I get a fifth volunteer to give me the last step here, the second last step? Oh, good God, this mother. Go ahead.
So it'd be 3 to the negative 15.
Yeah.
Y to the 6.
Great. Okay, can someone now please tell me, I'm only at 4.5 out of 5 in this question. I'm going to pick on you since you're sitting there so quietly in the back row. What's the last step here to make this correct? Great. Right. What we learned yesterday, this is one of those, probably the only new thing. I don't know how much you guys do with negative exponents in grade 9, okay, or 10, but what a negative exponent means is that it's 1 over, okay? So negative 15 in the numerator is positive 15 in the denominator. So in this class, we're going to have just use positive exponents. Okay, so it was y to the 63 divided by 315 x 15.
So every time you put it down,
Right
it
on.
switches the sign.
And the same thing, if you were to do something like, but you can also do the other thing too there, right? So if there's a negative in the exponent to begin with, that can move the numerator then with positive exponent. Right, so a negative means just right, flip from numerator to denominator and vice versa. That's how you do that.
Okay.
Okay, good? Ready? All right. Our lesson today, this is our actual first real lesson. Beginning of our fun lesson now. You guys are enthusiastic today. I can possibly tell a joke here. And this will hopefully wake you guys up. That's like copyright though. I sort of feel bad that I'm stealing that from the guy, but it's so cool. Alright, our lesson today is going to be called rational exponents. I know that was. Okay, rational exponents. Okay, what I'm going to do today and Monday is we're going to go through all our exponent rules. So we can do all the algebra with exponents. We want to apply them after that. Okay, the way I always teach every single unit is we do all the algebra stuff first, and we get the word problems and stuff like that at the end where you're good at, you feel confident in all your stuff, okay? Back from the last unit, what is something that's rational? What does that mean? Fraction, okay? So these are going to be fractional exponents. Because they don't. So we're going to say a rational number is a number that can be put in the form A over B, where B cannot equal 0. So what we're going to get into today is we're going to ask the question, can you have a rational exponent? And more importantly, what does that actually mean? Okay, like mathematically you can do a lot of things, but there's got to be some, logic to it of how we get it. Okay? And some of this stuff is saying, yeah, I got it, no problem. I don't think I can. No.
I was like, okay, and I thought like,
Sure, yes. No, maybe. Jessica, I want to do one example so you can see what we're doing and then go down to guidance. Okay, so what we're going to just wonder here is we're going to say, can you have a fractional exponent? What does it actually mean? That's what we're wondering in today's lesson. Okay, so we're going to say here. So what's the square root of x squared equal to, please? X. Okay. So let's say we do then in the same way. What I'm going to try and figure out then is we want to try and find a way to take that square root element and turn it into a number, okay, that we can type in here. So using the same thing, if I do that x squared to the y equals x, what's y going to have to be? What's our power rule there for that there? Okay.
It should be square root of y.
Square root of y, no. Okay, we're close though. Okay, right. Forget about square root though. What's our power rule? What's our power rule? Multiply, right? So 2 times something. What's the exponent beside the x on the right hand side? 1. Okay, so what we're basically saying is like 2 times something is equal to 1. What's that something going to be? 2 times what equals 1? Oh, goodness gracious me. 1/2, okay? So we're going to say then it's like x squared to the 1/2 equals 1. Sorry, x to the 1, sorry. So therefore, the square root of x is the same as x to the 1/2. That's what I just sort of showed. Does that make sense where we're going with that? Okay, right? So when you see it, no. So, what's that? Okay, so this is the same thing, I guess. I remember this from last semester, this is flashing back in. So all we're saying is, though, right, if you want to change this exponent 2 into a 1, right, you're dividing by 2, right? That's what you're doing. Okay, so what you're doing is you do 2 times 1/2, like the power rule here is to multiply, right? So 2 times 1/2 is equal to 1. So the square root of x, we said, is equal to that. The square root of x squared is going to equal to x. And then we're saying x squared to the something is equal to x. And that something happens to be 1/2. So that just showed us that the square root of x is the same as x to the 1/2. That's what we're showing there. Okay? So in the same way, Has anyone ever seen that funny symbol right there? Too many times? What does that actually mean? What does that actually mean?
Explodes through calculator.
No.
Cube root.
Cube root, okay? So this is going to be what's called the cube root. What a cube root is, it's going to be a number. When you take the cube root of a number, it's something that's multiplied by itself 3 times, right? So like for instance, the cube root of 8, the cube root of 8 is going to be 2, because then 2 times 2 times 2 is 8. All right, so that's the idea. So in the exponential form then, using the same idea, the cube root of 8, we're going to say is x to 1/3. Okay, so with a denominator of 1/3, because you're cubing something for that, the opposite of that. In general then, the nth root of x, what's the nth root of x going to be then? X is 1 over n.
So why didn't you just take off of that?
Because. Finally, x, the nth root of x to the m. Oh, here comes the fun part. What is the nth root of x to the m going to be in exponential form? Well, we already said the nth root was 1 over n, right? So
N
what's
over
x?
n.
Sorry? No?
That
Oh, sorry. N was x to the m over n. So what we've just actually shown now is that you can make any fraction. That's what I've just done for you. Okay, right? As long as you express something in a fraction, you can turn it into something that you can use a square root and calculate on your calculator. Okay? You will be needing calculators today. Does anyone need to go to calculator? No one? Perfect. No one. Almost everybody else. Okay, so again, let's go here. So basically, all I wanted you to learn out of today was this: if you can basically have a fraction, but you can answer the fraction here. Okay, so in your calculator, find okay, so this is calculator day today. So you're doing x to the power 4 over 7. There's 2 ways to do this. Okay, you can do it the 7th root of x to the 8 to the 4. I prefer you didn't do it that way. What you would do is you would use a button on your calculator that looks something like this. If you don't have that button, it may look like this. It may also look like this. That's your exponent button. Okay, right? Got it? So it's going to look like one of those 3 things. So what I'd like you to do is to type that into your calculator. X to the power 4 over 7. We'll go to 3 decimal places, please. What's that?
How do you get it to calculate?
If you have an answer in a fraction, that's cool. Press the fraction button. There should be an A, B, C button. Did you get a fraction? What'd you get for numbers? Or mess? Should be a mess.
3.21 and then a bunch.
How much, right?
3.281 a bunch of random stuff.
I think what happened, make sure you use the brackets on the right hand side, right? So 8 to the power.
Wait,
You said it's 11 better.
Here.
3.21 dot 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 dot.
Oh, yeah, okay.
Okay, so 3.21, that mess up? Was it 3.2? Okay, good. So take a second and do this again to make sure we're good here. Let's go for, B is going to say 152, 156, let's try again here, to the negative 2/3. Take a second. You don't yell at the answer. I like everyone to try this out because it's important that you can copy this down off the board. That makes me happy. Your penmanship is excellent. You have to make sure you can actually do the answer here. Tristan, I'll pick on you in about 10 seconds once everyone's tried it. Just remember the good old days you used to sit in the front row.
Yeah.
Remember those good old days?
Yes.
All right, 156.
Trio back here.
Yeah, 156 to the negative 2/3 is going to go like this. Tristan, go ahead.
I got 0.034.
Yeah, dot, dot, dot. 0.035. Now, how can I tell that looks good? Why is there like decimals in this question? Yeah, go ahead. Negative exponent, right? It's like 1 over 156 to the 2/3. All right, so it's going to be like that. We'll do one more to make sure you're feeling good about yourselves here. Yeah, I'll do that one. Let's do this one. Let's do this one. 1.005 to 324. I'd like you to use 6 decimal places, please. And then we'll get to the hard part for you last one. These are the hard part, let's do the fun part. Maybe 6. As many as you can have. 6 will say, okay? Now, if you've been in my class before, you'll know where this is heading very soon. Right? If you haven't been, I'm not going to spoil the surprise. Don't spoil the surprise. What? 1.005 324. I pick on a random person. Joel, can you give me 6 decimals, please? Go ahead. Oh. Did you get the other one?
Brad, you need a new calculator.
Sorry, I lost that number there. What was the number for this? How much? A little louder.
1.1758. 10636.
I didn't get that.
I think you used too many. I think you did too many zeros. You did 0005. What was it?
5.03273.
Sweet.
Yeah.
Okay. Okay, good. Okay, so we're all feeling good with our calculators now. Okay, because that's the purpose of this activity, just to make sure we're good calculating. Summary, you're good? Okay. Yeah, I guess soon, but I'm not yet. Don't clear
Where's it any of that sort of American
I'll tell when I pause so I'm good. Actually, it's a good time for pause. Yes. Okay, I'm just going to pause 7.